physicists, today I'm going over A-level dynamics. Now this is mainly focused at OCR A, but if you do AQA, you may also find this video really useful. What I'm going to go over is I'm going to go over what we mean by dynamics, and then I'm going to go over two of the most common types of problem that we see when we're solving any dynamics question. So don't forget to check out my resources on the My Edspace website if you want the notes for this topic, or if you want any worked examples or anything like that. And don't forget to check out the link in the description of this video to see about joining our live lessons. Right, let's jump straight in. So dynamics are about when objects are moving, but it's not about any moving object. Because remember, if an object's at constant velocity, according to Newton's first law, that must mean that there's no resultant force. So objects moving at constant velocity are in equilibrium, which is another video. When we're talking about dynamics, we're talking about objects that are accelerating, okay? So we're talking about when we have a resultant force, so anything to do with Newton's second law. That's what we're talking about when we're talking about dynamics. So one of the really common problems that you see is like this one here, where we've got a block that's sliding down a slope. So what we need to do first is we need to find the component of the block that is sliding down the slope. Because the block is moving this way, so I need to break down this weight force into the component that's moving down the slope. So I'm going to break it up like this and like this. So I've got a component of the force that's parallel to the surface and perpendicular to the surface. Now, I know that if this angle here is 20 degrees, that angle there is going to be 20 degrees. This is the opposite here, so I'm going to use sine because if I want to find the opposite and I've got the hypotenuse, I need to use sine. So this side here is going to be W sine of 20. Now, that's the force acting down the slope. So if there's no other force acting down the slope, I could rearrange Newton's second law. The resultant force is equal to mass multiplied by acceleration. Because if there's no other forces acting on this box, like no friction, anything like that, I could simply rearrange this if I knew the mass of this box was m, to find the acceleration would be equal to W sine 20 over the mass. But if I've got friction or something like that acting on this box as well, that starts to become a little bit more tricky, okay? Now, remember that this F here in Newton's second law is for resultant force, okay? It's all about the resultant force. So the first thing that I need to do here to then use this equation is, instead of doing it like this, I need to work out what the overall resultant force on my object is. The friction always acts against motion, so it's still parallel to the surface, it's just going in the opposite direction. So actually, I can just go back to my good old-fashioned GCSE rules of if I've got arrows like this, I can add them, and if I've got arrows like that, I can take them away. Because the force is in the exact opposite direction to this W sine 20 down here, to find the resultant force, I can do W sine 20, take away the friction, and that would give me the mass multiplied by the acceleration. So if I wanted to find the acceleration in this example with friction, I'm going to do W sine of 20, take away F, divided by the mass, and that will give me the acceleration. So this is the other most common type of problem that we get when we're talking about dynamics. So we've got a trolley that's being accelerated by a hanging mass down here. So this weight is providing the resultant force. Now most students go, oh yes, F equals ma, F over m equals a, right, fantastic. The resultant force is going to be the weight. I know the mass of the trolley, that's capital M. Happy days. That's not actually correct. What most students forget in a problem like this is it's not only the trolley that's accelerating, it's also these hanging masses. They're also going to be accelerating at the same rate because this system is accelerating as a whole, okay? So in this case, this mass is not actually the total mass of the system. What we need to do is we need to work out what the mass of these weights are going to be. Now, I can just use my equation. W is equal to mg, rearrange for the mass of the weight, which would be W over G. And then I need to add that to the mass of the trolley. So the total mass of the system is going to be capital M plus W over G. I'm going to take this and I'm going to pop it all in there. So it'd be capital M plus W over G, and that's how I would find the acceleration of this particular setup. So I've just gone over to the most common setups we get in dynamics, but hopefully I've given you some ideas of things that you're going to have to look out for. Remember, dynamics are when we're about finding the resultant force when we've got an object that's accelerating. So you're always going to need to use F equals ma, Newton's second. Let's just check I get that right. Newton's second law. Newton's first law is equilibrium. Stuff that hasn't got a resultant force. Dynamics, Newton's second law, stuff that does have a resultant force. Anyway, I really hope that you found this video useful. Don't forget to check out my resources on the My EdSpace website if you want the notes for this topic, or you want any more worked examples or any extra questions. You can have a look at the link in the description of this video to see about joining my live lessons. And whilst you're there, you can subscribe to this channel at the same time. Thank you so much, and I'll see you soon. Take care now.